Hello, everyone. Welcome to the Canadian Electricity Association's Conversation webinar series. CEA is the voice of the electricity industry in Canada. My name is Farhan Mirza, and I'm pleased to be your host for today's webinar. I would first like to begin by acknowledging that the land on which I am broadcasting you from today is the traditional unceded territory of the Algonquin and Anishinaabe people. The Algonquin peoples have lived on this land since time immemorial. I'm grateful to have the opportunity to be present in this territory. I'd also recognize Canada as the land of the First Peoples, Inuit, and Métis. I would like to pay homage to the Indigenous peoples, past, present, and future, that continue to work, educate, and contribute to the strength of our country. I'd like to recognize that the land is shared through historic treaties, developed through contemporary treaties, and one that continues to be unceded territory. Conversation series features presentations from CEA's corporate partners, and the series will highlight a variety of Canadian and international solutions to current and future challenges faced by our industry. Working with CEA's corporate partners, these webinars have been developed to be of specific interest to those working in the electric utility space, from generation through to the customer. For a list of upcoming sessions, check out CEA's website at electricity.ca. Before we get started on today's session, there are a few housekeeping items I'd like to go over. Our session today is scheduled to run from 1 to 2 p.m. Eastern Standard Time. Questions can be asked, and we'd encourage you to do so as they come to mind by typing them into the questions field on your screen. They will be asked at the end of the presentation as time permits. And a brief survey will be sent to webinar participants following the session today. We'd very much appreciate your candid feedback, as we are interested in any topics you'd like to have covered in our series in the future. And lastly, please keep an eye out for future webinars and events through CEA's monthly newsletter called Current Affairs. With over 6,000 subscribers, Current Affairs, much like the national newspaper, is the place to go for Canadian industry news as we connect the national value chain from generation to the customer. If you'd like to receive Current Affairs, you can subscribe to this free publication again on the CEA website at electricity.ca. Today on the Conversation series, I'd like to welcome G&W Electric, who will be helping us learn about the latest in high voltage Recloser technology. G&W Electric will introduce their latest product in Recloser technology for the high voltage market. Today's webinar will discuss the features, benefits, and advantages of utilizing this technology versus current solutions. A facilitated Q&A again will be conducted at the end of the session. To take us through today's presentation, I'd like to welcome Harold Herz, who's Global Product Manager for Overhead Technologies at G&W Electric. Harry, welcome to the Conversation series, and I'll pass it over to you.
Ron, thank you very much, and very excited to be here. Thanks for the great introduction. In this particular series is a platform we're always eager to participate. Again, my name is Harry Herz. I'm the Global Product Line Manager here at G&W Electric. And so what that means for us is anything that's above ground is under my bailiwick of responsibility. So my background is educated at the University of Dayton, registered state of Ohio as a professional engineer. About a little over 30 years of professional experience in the electrical industry. Started from utility side of the business in American Electric Power in Cleveland, Ohio, in Columbus, Ohio. Here in the States, progressed through a lot of different elements in that particular, from substations to protection and controls. And then I proceeded to work on the manufacturing side. Based on all the experience, it's been a really fruitful journey. We participate quite heavily here at G&W Electric, as all our colleagues do, and several of our users here on this call, with the IEEE 37, the switchgear standard. Lots of different elements of that particular standard. A lot of distribution products is that we're on the subcommittee, and I'm the working group chair. One of the key elements associated today is really innovation. We're really excited again to talk about what we have to offer here in the industry. But before we get started, we'll kind of go through a few things here in terms of an agenda. We'll give you a little quick overview of G&W Electric. We're going to focus on the grid challenges in today's technology and advancements of technologies, and kind of introduce you to the new product here at G&W Electric as the first high voltage pole top recloser. And then we're going to finalize this particular presentation with a case study, one of our partners, and share a little bit of the content of what they've executed and what their missions are. Again, just a quick brief history associated with G&W Electric. We're entering our 117th year, so quite proud of that level of existence. We basically started in 1905 with a small company, but it consisted of two electric utility, Commonwealth Edison here in Chicago. Basically started the business, worked on original porcelain potheads, progressed to different switches, until they've basically progressed until the Mueller family purchased the organization. So again, we're a privately held organization. So in 1977, the Mueller family bought the company and then progressed to where we're at today. Our John H. Mueller is our presiding CEO and majority owner since 1994. What we'll actually go through some of the content of what we've done here, but really just a brief history associated with distribution products is where we started creating more of our innovations, again, from the first solid dielectric dead front recloser out on the market in the late 2009, 2008 timeframe to the very first visible brake and underground solid dielectric pieces of a switch gear, and then progressing obviously to some of the things we're here to talk about today. Here at J&W Electric, we're really focusing on power grid solutions. Majority of our success and our ownership has been around in the distribution product. As I mentioned, some of those state-of-the-art, very first in the industry. But those technologies and those solutions give us the platform and the springboard for what we're about to talk today. And all these designs and products are really focused on safety. We understand that is the most integral part of development and manufacturing is safety for both our customers and our workers as well. The integrity, the quality associated with that particular initiative, we take quite seriously, and really basically is the platform. What we want to offer is solutions that are here to last for a long time. The art of being able to develop and design innovations really comes from our customers. Though yes, we have lots of different creative engineers, but listening to our customers since 1905 has really been our focus. It's really kind of a consulting approach where we listen to what our customers are asking for. We understand our strength and our capabilities. And that experience and listening allows us to actually gravitate to providing very unique solutions and innovations that basically will meet the initiatives for the power grid for long periods to come. So again, as I mentioned, the focus today is the grid challenges. So we understand working in electric utilities, there are many challenges. The things that are really important to obviously our customers is keeping the lights on. So here's a list of some of the current challenges, grid challenges. Again, we all understand that we've been established, even from a company standpoint, the electric industry also has been established for quite some time. So one of the major challenges on the grid is aging infrastructure. That coupled with severe weather that we've experienced, whether it's the high winds or the heavy snows in this part of the regions, or the flooding, or the fires, are all really challenges to keep the lights on and the power grid active. The reliability associated with keeping a very sophisticated, integrated, the world's largest integrated electric industry is here in the North Americas. They are the most pronounced infrastructure, and obviously the capabilities of keeping that grid intact is really critical. The cost of maintenance. So every particular piece of aging equipment will require more and more maintenance. Some of the technologies that are out on that particular platform require a certain level of maintenance to keep them functioning and the capabilities of what they were designed for. Today we see more than ever a very exciting time is the power grids. The power grids of distributed energy. Even here at J&W Electric, we're actually establishing a microgrid for our particular resiliency to be able to keep our production. So again, exciting news on that to come later. The challenges associated with power flow, the ability to push current and pull current to wherever it needs, critical customers, infrastructure that need energy and electricity to be able to perform their particular processes or services. And real-time monitoring, the ability to actually detect what's going on in the grid so quick and appropriate decisions can be made is really one of the critical challenges. The need for more controls. The sophistication at the level of controls is quite unique. Again, it's very pronounced inside substations and kind of been at that level, but now all the infrastructure outside those fenced-in areas is really now becoming more and more pronounced. The capabilities, the speed, the energy associated with putting that technology is one of the major challenges. So what's the answer? Well, solutions, right? Every time we have a manufacturer, alternatives to devices that are outside, the same level of sophistication that's been traditionally reserved for the inside the fenced area now needs to be made available. You start to see that capability out in the distribution quite extensively with automation and the capability to isolate. A sensing technology and relay-based protection. Sensing, the accuracy of sensing, the capabilities of real-time monitor is one of the solutions that are really critical to match up with those challenges we've just identified. Alternative solutions for insulation. SF6 and oils have been predominant at certain levels of voltage classes. So you get to the high voltage levels or the sub-transmission levels, and some of the alternatives are really just still around that technology of SF6 and oil. So having an alternative, a maintenance-free base concept, is one of the solutions that is really powerful. When you start talking about innovation and the infrastructure needs, you start talking and thinking about the total life cycle cost. So what you see on the left is basically a pyramid. When you're actually looking at making investments in infrastructure and the technology, it's always really the thing that you always see is the purchasing price. But there's a whole lot more underneath that surface that's really all part of the infrastructure that's required to make an investment. It's the operations cost. Again, things like monitoring, maintaining, making sure things are working and functioning, and then whatever level of content that needs to be present and the mechanism is there is really critical and is a lot of operational cost. Again, the service and the maintenance to be able to keep that particular product or those products that have a high maintenance or certain levels of lubrications is really all part of that. And again, environmental impacts, everything in terms of like where this particular product is placed here in the North America. In the Northeast particularly, we've obviously seen some challenges in the winter. So that environmental impact of basically the freezing, the icing, the high winds are all part of this installed infrastructure. So it's that combination of that total cost is really important. And again, having sophisticated solutions that may have a little bit higher upfront cost basically allows that under level costing to be significantly less. So technology innovation needs today. So what is the market looking for? What are the particular things that are important when making these decisions about innovation? Okay, so one of the really key pieces is manufacturing investment in the future. Ability for manufacturers to go beyond the basics of what we actually do to keep the lights on is a significant investment. So utilities are looking for manufacturers that invest in R&D, basically have people on staff to start thinking about that next solution to keep the grid up and running. And having partnerships with customers identifying tomorrow. Again, everybody understands what's in front of them today, but a lot of times it's so much energy focusing on what to do today that you don't have enough time. So having a manufacturer that thinks about whatever's needed in the future is really critical. And again, as we talked about performance on the grid, the reliability, the resiliency, those are the critical elements that manufacturers need to focus to be able to provide innovation that meets our market needs. And the other piece is really kind of the software side of it. It's the power automation expertise, having a manufacturer that has a capability of dedicated power grid automation teams on hand, dedicated from the owner or the ownership, such as the CEO, the operating, making sure that the actual elements of taking all this sophisticated high capabilities and have it function is really a core part of what a manufacturer needs to have. And again, delivering that capability to match our users' needs. Well, it's full-on SCADA capability, or what we'll describe as scalable integrated solutions. So an investment on the front end side will have an actual first step into that full functioning automation and grid modernization that's required. So all these are the technology innovation needs when you're actually making such significant investments in the market. Okay, so let's get into technology advancements. One of the things you talk about when you talk about technology as innovations is understanding and learning the infrastructure. So today we talk about certain things, and again, the power grid, the high voltage levels. Again, what we're going to talking a little bit more is what we describe in different utilities as the sub-transmission levels. Certain levels of voltage levels up to about 72.5 kV is categorized as sub-transmission. It's a really critical part of the infrastructure. But what you see here on the screen is several different what we'll describe line constructions. Very simple in their concept, vertical construction. You drive down the road, you guys are all part of the infrastructure maintaining, but it's basically conductors that are sitting on top of each other. So that's one level of infrastructure that needs to be supported. So the technology that's available outside those substation fences, what you describe here is maybe motor operator air disconnect switches, the ability to have some kind of attachment to it to actually do a little bit more than just breaking of deadlines. It requires particular attachments, and some of those attachments might be SF6 to be able to interrupt a certain level of current that may be on that particular line. You know, surge arresters, SCADA systems can be utilized to start to sectionalize in that infrastructure. But all these capabilities have their inherent maintenance and associated with environmental exposure. The other type of configuration is a horizontal construction. And again, this is where the conductors sit side by side and the infrastructure may be a little bit different. So these are all the legacy solutions that are existing today that are existing outside that substation area that needs another level of automation and innovation. So at this time, we'll take a pause and we're going to actually have a polling question for our participants here to actually give us a little bit of input. So you should see on your screen a question, a series of selections. So take a minute to make what selection makes sense to you. We have about a minute and then we'll be able to produce the results of our polling question. Okay, we'll give about another 15 seconds here and then we'll close the poll. Okay. All right, we'll close the poll. Do we have our results? Let me share the results here. Okay, we'll move on here. So again, thanks for the participation on that. We have one other poll towards the end of the presentation. So we're happy to introduce again, now we talked about the legacy solutions, we start talking about the solutions that are available. I mentioned a few of those particular technologies that are out there that are combative to those particular challenges. And one of these particular solutions is we're proudly to introduce the Viper HV. So this is the first sub-transmission recloser. For some of the audience participating in the distribution, recloser is a very pronounced device designation, so you're familiar with it. But outside of the capabilities up to 38 kV, reclosers do not particularly have an actual product or solution until now. So as a leader in North American providing reclosers and expertise around reclosers, we've actually been charged with one of those particular listening events that we talked about to actually develop the very first sub-transmission recloser. This is a particular product that's designed to actually be implemented outside the substation. All the capabilities of what the devices inside the substations are now available to our customers outside the fenced area. G&W Electric's commitment around the quality and service and support really is the focus and the actual backbone for this product so that we are actually delivering the same level of reliability and proven technology that we utilize for quite a long time in our distribution customers. So with this development of the very first pole top recloser, our customers now have an advanced and additional zones of overcurrent protection, the ability to fault isolate, to turn off adverse conditions of temporary nature, and actually restore the particular adverse conditions after a momentary turning off the electricity. So it, again, providing a device that's outside the substation that has the same capability as the substation device now provides our customers with the true ability for isolating temporary faults and only impacting or turning off those particular customers that are downstream of the adverse condition. It's uniquely designed, and we'll get through some of the particular content and the details, but we're basically taking an integrated package solution. It's a recloser, CTs, and integrated voltage sensing, and now putting it in a complete self-contained package and allowing it to be dispatched and deployed out on the sub-transmission line. These enhanced zones of protection are really powerful in the fact that when an adverse condition occurs, the substations have to communicate, or maybe they don't communicate with each other, but they'll turn off the whole infrastructure in between every existing line. Now basically creating configurations that are flexible, a variety of configurations that are strategically designed to match up with existing infrastructure is really important, because now they have the capabilities not only providing enhanced technology, but in a form factor that matches up with the existing technology that's out there. Again, it's designed to be a modular solution. It's a turnkey, meaning that we provide all the core components to basically allow you to dispatch that without a lot of effort. And again, its platform, as we get through, is maintenance free by nature, which means it's super cost effective and being able to provide enhanced reliability and transmission grid resiliency. The application is really what we would describe as we've done quite frequently on the distribution, is to design and utilize the ability to turn off and reduce the number of frequencies out on the sub-transmission line. Again, when you see your lights flickering at your home, obviously that particular infrastructure is designed to do that. So bringing this technology, now we have the capability of creating this infrastructure right on the sub-transmission lines. So again, being able to split out the lines, be able to isolate it with quick, high-speed detection, fault isolation, and then quick restoration is super powerful. All the tasks, all the infrastructure that exists on these sub-transmission, they could be industrial customers, they could be interties with other utilities. These are really traditionally just manual unless you drop in a full-fledged substation. This particular product, what we describe as select for substations, it is intended to be for those particular infrastructures that require potentially protection on a transformer or a switching station. So this is, again, a full-fledged fault interrupting, fault detecting device that's self-contained. So it doesn't necessarily need the complete infrastructure of a complete substation. The application of reclosing, that is a concept that we can all kind of understand. And again, it exists in the substations today. It's the ability to actually, through current detection, find an opportunity where the current or the voltage is of an adverse level, and you turn off the circuit. And again, quickly being able to turn off, isolating that adverse condition, and if it's of temporary nature, that restoration, that reclosing will allow a very short outage and a complete restoration once that temporary fault is cleared. And again, it could be a radio configurations, or it could be in these loop schemes where you're talking peer-to-peer between relays. The concept of sectionalizing the switches, that's really kind of what exists today. That's the legacy solution. So this has typically only been able to be met with air disconnect switches, and ability to motorize them gives some level of very limited, but ability to do some isolation under a deadline configuration. Now you can actually deploy an actual fault detection, so it can do complete fault isolation through load break switching. It could be designated as an open tie position. And again, as I mentioned, it could be designated. That particular sectionalizing a switch is really the core infrastructure what this product can provide with the enhanced capability to do fault isolation and reclosing. Packaging it with a sophisticated control gives us what we would describe here at G&W Electric as a basic necessity, and that's an automation platform. Ability to have sophisticated mechanisms up in the air with a maintenance-free platform coupled with a sophisticated control gives us that capability for that full system reconfiguration. It can be dispatched and deployed as alternate serve for sub-transmission customers. You know, this particular fault isolation and restoration capability is all built in with this particular Recloser solution. I'll take just a few minutes to talk a little bit about the components. Again, integrating wildlife protection through custom solutions. The core of what we talk about here in this particular product, which is very unique in the market at this voltage class, is the solid dielectric. Again, no gases or oils that's required to keep that high voltage from going to earth. You know, terminal connections integrated to be able to connect to that infrastructure. I'll show you in the next slide as well, but the currents and sensors, current and voltage sensors embedded keeps it a very low profile and compact solution. You know, having manual trip panels to isolate, to turn off under adverse conditions, or to do a trip and lockout, that's all integrated in this particular solution. The 360 visual indication that's on the bottom allows this particular product to be dispatched quite high in the air in a sub-transmission. Having integrated pole brackets to match up with the infrastructure is really powerful. The next slide is just basically a little bit more of a deeper view. Couple here, and it basically kind of gives you a little bit more of an X-ray view. It's a vacuum interrupter technology that's utilized here. That is a single vacuum interrupt that's rated all the way up to 72.5 kV. Again, as I show you on this particular slide, that side bushing is basically where an integrated bushing current transformer. And again, for the very first time in this particular voltage class, we have integrated voltage sensors. The capability of bringing voltage detection down a single cable down to the control is super powerful. Again, certain elements you see in the blue, that's basically the solid dielectric insulation. So this is utilizing that field proven solid dielectric that we've been dispatched around the world in our distribution products. We utilize it here. Unique property that we do a little different in this particular, we basically will overmold silicon skirts to give us that outdoor weatherproof, that creepage distance, keeping that contamination, and a silicon formulation that's super robust in terms of contaminations. So the environment is completely encapsulated, all the high voltage in a sealed environment. And again, I talked a little bit about the 360 indicator ability to kind of see, and everything is powered through a magnetic actuator. So we're basically driving that vacuum interrupter appropriately at the right speeds to open and close, and actually performing the optimized capability of that vacuum interrupter. I'll share with you just briefly some of the ratings. The ratings we basically have dispatched in solutions from 40 kV to 72.5 kV. You know, our initial release is at 1200 amps, continuous current. We have another solution that'll be due out here shortly that'll have 2000 amp capability. The fault interrupting, the ability to turn off is all the way up at 31.5 Ka for this particular product. So very powerful interrupting capability embedded with this solution. You know, it's got a 350 kV BIL. Again, ability to withstand 160 kV. So for the short time, you know, again, these are really powerful capabilities with this product that were traditionally just reserved for SF6 and oil insulated solutions. One of the things I'll point out on this slide is the mechanical endurance. One of the things that we talk about maintenance-free platforms, its ability to not to monitor certain things as oils or SF6s, but also to have the capability of this mechanical endurance. The ability to operate 10,000 operations in this voltage class is essentially unheard of. It doesn't necessarily mean the infrastructure of the sub-transmission is ever going to require 10,000 operations, but it's a sign of mechanical endurance, the minimum amount of moving parts. So when you actually put this apparatus up in the air, you're assured again of that maintenance free. You don't have to worry about lubrications or things breaking or things having mechanical issues once you dispatch it. So again, really powerful ratings to match up with the infrastructure. This particular slide, we're going to talk a little bit about the platform. Again, the pole top design, again, that ability to create an infrastructure, and you see these particular modules are very flexible in their infrastructure. That flexibility allows us to package with different relays. It allows us to match up with the infrastructure, and it actually gives us a physical construction with a minimum amount of reconstruction of conductors in the lines. So at this time, I'm going to share a little bit of a couple brief presentations or at least videos that kind of give you a little bit of flavor of what some of these particular solutions look like. Again, they're very short animated videos, and we'll share those with you now. The first one I'll share with The first one I'm sharing with you is just a very physical vertical configuration. Again, strategically placed along where the conductors are. Again, customized, automated. So again, a very compact solution that matches up with the vertical construction. I'm going to share one more particular video on the terms of the horizontal configuration that I mentioned earlier. So we'll go ahead and start this short animated version. This physical configuration, again, is very similar in an individual module, strategically placed in where the horizontal, but it has a cross arm, two structures that basically allow us to span across wherever that horizontal conductors. And again, just a very simple video presentation associated with, with the actual infrastructure is really a powerful solution. So again, moving along here in terms of the features and benefits, I mentioned a little bit about operation in terms of a manual trip lever, but one of the things that solid dielectric, that proven technology is really critical. Again, that solid dielectric is typically been only available at distribution class equipment. So coupling again with mechanical devices such as a mechanical trip and lockout gives our customers that capability of not only isolating or opening it through mechanical provisions, but when that mechanical handle is dispatched, we actually physically block and electrically block. So again, this is a capability and functionality that's really critical to our users, and obviously the safety and integrity of the grid and our personnel operating it. The features associated with what we call a compact 3-in-1, which we mentioned earlier, that is the integration of a recloser mechanism, that vacuum interrupter, that solid dielectric, that magnetic actuator, all coupled together with current, embedded current and voltages, gives us that really compact, first of its kind in the industry, a solution that didn't have external components to provide that capability. The integrated current sensors are really a multi-ratio. Again, we basically bring a bunch of different taps, 5 wires down to the controller for our users to actually select which particular ratio meets and matches their sensitivity. So again, we can go through a full 2001 ratio or a very sophisticated low continuous current 300-to-1 ratio. That flexibility is super powerful for our customer to have one size fits all. The other piece I mentioned that's quite unique in this innovation is the 15,000-to-1 internal voltage sensors. So for the very first time in the industry, voltage sensing can be detected internal and brought down to the control. Again, a very powerful to have both current and voltage brought into the control to making sophisticated decisions. One of the things that's really powerful and quite different from this technology that exists in substations, everything is modular, everything's a plug and play. So a connector eyes up at the mechanism for quick connection, and then quick connection down at the control allows our installation to be super seamless, and again, reduced in potential for errors. Again, having that level of plug and play uniform platform and have all the flexibility allows us to cover a lot more application and far reaching. The Viper HV features and functions. Again, I mentioned what we describe here at G&W Electric is a backbone of what we do, and that's automation. That automation, that capability of having a sophisticated mechanism that bring all that analog and decision making, a maintenance-free platform, and bringing that into a sophisticated controls is quite powerful. That grid automation system, the capability of not only taking a very sophisticated and revolutionary investment in terms of this Viper HV, but having the capability or an infrastructure or partner that can also plug that sophisticated device directly into your infrastructure is super powerful. And again, it basically can be plugging and play into your infrastructure. It can be scalable in terms of you can make the investments and capabilities now and then actually grow into a full automation. But the investment now, the capabilities of putting automation out on the grid is super powerful, and now it obviously allows us a very unique perspective and capability to, again, bring a certain level of innovation and system reliability and resiliency to the grid that hasn't been able to be performed before. So what I'm going to take a little bit of an opportunity at this point, I'm going to ask for our second and final poll. So again, we'll go ahead and run that poll and ask a few more questions here. Okay, we have about another 30 seconds here. Again, just take an opportunity to make your selection that makes sense for you. Okay, about another 15 seconds or so.
So the poll is concluded. You should be able to see the results there now.
All right, great, thank you. All right, well, thank you for your participation in our second poll. So the last part of our presentation is really giving you a feel for how all this innovation and all this hard work comes together. So what you see on the screen is really our Northeast utility partner. So with every sophisticated revolutionary invention, there's actually several different people and partners involved. And one of those particular partners has been an investment both on their end and our end to actually jointly come together to provide what you see here today. This particular utility is one of the very forward-thinking visionaries of what their particular infrastructure was and what it can be. So you'll see particular still photos here in terms of the installation. So this particular solution was dispatched just before the U.S. American Thanksgiving and has been active. And this particular utility has actually been making particular installations and continuous flow of purchasing. So again, this is where the fruition of innovation comes together. And what I'm going to do is share with you a video to kind of give you a little bit more feel for that particular this particular installation and the value. Well, again, thanks for the participation in this particular, again, quite exciting in terms of seeing all the hard work for multiple, both the utility side, and you can see the infrastructure that came together to actually make a deployment of innovation. Again, the concept of a good idea is obviously sits in this particular room, and we're looking forward to obviously sharing more enhanced innovations. But at this time, I'll turn it back over.
Excellent. Well, thank you so much for the presentation, Harry. It was really informative and insightful. So, and appreciate the audience taking time to participate. We will open the session to Q&A now. So, again, a reminder to our audience: as you have questions, please type them into the questions field, and as I receive them, I'll ask them of Harry, and we'll get that going. So, a couple of questions came in while we were in the presentation. To start off, Harry, what is the INT capacity operating time, rated current, and the capacitor switching capability of what you described there?
Yeah, great. Right out of the bat, a real technical question. So
Yeah.
thanks for that. Yeah, so a couple different things associated, and again, we didn't get into a lot of the details of testing and the sophisticated testing in the platform, but this particular product is tested under what we would describe as a Recloser standard, 37.60. This is a Recloser standard that's rated up to distribution class. So part of that particular standard doesn't have the capabilities of the current and the voltages at this voltage level. Again, we're all the way up to the 72.5 kV. So this particular, again, two elements of that question. This one was tested and certified with the capability of cable charging, or cable dropping is what the term is used, and that is a representation of capacitor switching capability. Again, this is a fault interrupting device, but it does have to have a core element of both be able to de-energize the line and actually de-energize what we'll describe as loaded cables. These are underground cables that will simulate equivalent capacitor switching. And this particular product was tested and certified with a C0 class at 250 amps of capacitive switching capability. The other part, I think, is a question about capability to detect fault and isolate. So this particular, upon receiving command from the controller, again, the sensing, whatever particular time characteristic or whatever relay and protection, from receiving the command to complete execution, extinction of the arc is 40 milliseconds. So again, that's the total clear time from command to execution. I think that's what the question was implying.
Yeah, perfect. Thanks for that. So we got actually a bunch of questions, so we'll try and fire through them as best we can in the time provided. So next question: does G&W provide a power supply and communications package?
Yeah, it's a very good question. So one of the things that's quite unique is every particular user has a different level of flavor of solutions. Again, what we pride ourselves is really kind of creating what I'll call as a basically uniform platform, or almost to agnostic, relay agnostic. And what that means for us is that we basically create from a power and drive module, basically we'll take either it's a 120 or 240 volt AC or 220 volt AC. The controller is flexible in terms of auto syncing to whatever voltage. But once that external voltage is provided to the controller, our power and drive module actually give us and deliver all the power supply. It's a power supply for the 125 volt DC that runs the relays, the 24 volt and for the comms equipment that can be integrated to the controller, and also basically ability to do battery charging and battery basically monitoring. So the answer to the question is we have the flexibility of integrating any type of communications from cellular to modems to Ethernet to fiber. It's all embedded in the capability. So whatever the selection of the relay, and again, we didn't really talk too many about the relays, but again, we've platformed on a couple different relays. Our partner, Schweitzer Engineering, we partner on what we'll describe as a high performing reclosers control in the 651R2. That is the state of the art recloser that the distribution folks utilize, and the SCL 421. So either one of those particular platforms are available today at launch, and that comms equipment, ability to packaging whatever that infrastructure, it could be cybersecurity, it could be security gateways, it could be sync locks, all that is ability based on all the power capabilities of the power supplies today. We can run 2 relays two powerful relays as I described, up to 3 different comms pieces of equipment, again, satellites, security gateways, all packaged in this solution. So we are user friendly and exactly will match up with whatever infrastructure that's required by our customers.
Right on, thanks, Harry. Next question, are there any limitations to use Viper HB at lower voltages where higher interruption capability is required?
Yeah, there's no limitations in terms of the physical product's capability. Again, detection for the voltage sensing that's on board can be could be implemented all the way down to a 40 kV system. You know, we definitely have customers that are going to deploy this particular product on their 44 kV systems, their 46 kV systems with no issues at all. Clearly, it's overrated and over insulated in terms of its capabilities, but the fault current, obviously that functionality and an ability to detect the voltage sensor are all embedded with that solution. So it's essentially a range taking product from 40 to 72.5 kV.
Awesome, thank you. Now, how do you provide clearance points for using this Viper?
Yeah, that's a good question. So what you saw a little bit in the video, and we didn't spend a lot of time, there's a certain level of demarcation for isolation. Again, we're using vacuum interrupter technology, so you can't see the vacuum interrupter's open gap. It's highly reliable, highly robust, but the infrastructure was typically required, and again, depending on your operating practices and procedures and infrastructure they utilize, you may dispatch disconnect switches. So our partner that we showed here in the Northeast utilized inline disconnect switches to give a visual gap. And this particular utility also had on the backside of that phase over phase construction is a bypass switch. So those particular elements can be packaged solutions. And for our partners with up to date and as the early releases, we've been utilizing whatever's on their standard. They've been dispatching and supplying most of those infrastructures, but again, isolation disconnect switch, inline hook sticks, you know, and those bypass switch are all kind of the overall package. Also things like surge arresters, right? Dispatching surge arresters or implementing surge arresters, all part of what the core capabilities and the competencies of what we described as site ready. Our core focus at release is going to be around, as you can imagine, the recloser mechanism, its capabilities, the cabling obviously important, and then the control functionality. We are working with every one of our partners in the utility industry to figure out what level of investment and or interaction modeling to match up with their infrastructure. So again, it's a partnership in figuring out exactly what particular components that we can supply that add value to our utilities. But we're going to utilize obviously whatever is available in terms of their standards and what they utilize on their system to integrate a complete integrated solution.
Great, thank you, Harry. You mentioned you were talking about some pictures that you showed during the presentation. They show the reclosers mounted on steel poles. Can you share how heavy those reclosers are?
Yeah, sure. So the reclosers themselves, the combination of the 3 phases is going to be around 3,600 pounds for a full installation. Again, depending on the particular hardware infrastructure, and the controller is going to be anywhere from the 350. So, you know, total weight by that infrastructure. And again, in that particular case, is you know, something less than 4,000 pounds for the total equipment. The infrastructure of a steel pole versus a wood pole or traditional wood poles is going to be a couple things. Obviously, it's the weight of the apparatus, but also the functionality. In that particular case, they're dead ending the transmission line. They're utilizing inline disconnect switches, and their platform is to utilize a 2-piece steel direct buried pole. So that was their platform. So the infrastructure of pole structures obviously is going to have both the compounded by, you know, obviously the apparatus weights and infrastructure, and then whatever supplement piece of equipment that's required, such as, like I say, dead ending or terminating into the pole.
Excellent. Next question is, will the internal voltage sensors allow the recloser to utilize distance or impedance relaying schemes, or will it be limited to overcurrent relaying?
Yeah, it has the capability. We actually did some simulated tests with our partner at the power. What we use this particular in Kima Laboratories in the Netherlands. So we've simulated the performance of the voltage sensors and shared with our partners in Schweitzer Engineering. So it has the capability to respond for permissive trips, for underreaching, so it does have the capability and the response to be able to be implemented under that functionality. So it's not just limited to purely directional or overcurrent protection, or over voltage protection.
Over voltage. There was a question here on, does it provide protection for under frequency as well?
Yeah, it has capability integrated, but whatever controller, so it has purely has a capability of doing under frequency. It's one of the easier functionalities that's available.
Okay, perfect. Are cable dip and surge arrestor brackets available for this product?
Yeah, it depends on, again, what part of the infrastructure, what utilities we try to match up, whatever's on standard. So for example, there's an inline inline arresters that were utilized by our utility partner in the Northeast that obviously had a good form factor. Again, it kind of goes around the strain release. There are also variations of maybe substation class devices. So with each one of our customers, if there's a particular arrestor that's on standard preferred, we've obviously like to kind of implement and package that together. So it is, again, around that collaboration of what infrastructure that's available. It's on standard. We'll look to model and actually supply that as well.
Thank you. Will they have the ability to single phase trip and 3-phase lockout?
You certainly do. We have not particularly come across a higher voltage customer that has the vision to go single phase tripping yet at either 40 to 72 kV, but it purely has the capability of doing isolated switching, so single phasing, and then 3-phase lockout. Today it's pretty much been dispatched as 3-phase operation, electrically synchronized, meaning that first phase to operate to the last one is within a quarter cycle. But again, based on its nature, we strategically made them individual poles, obviously for the form factor, so that we can actually model and put the mechanisms in close proximity to the conductors. And again, having a robust magnetic actuator that has super high speeds allows us to give what we'll describe as 3-phase gang operated, but again, in an electrical form. So again, 100% has the capability to do that. So we just haven't seen a customer with the vision yet at the 69 kV to do that, but we're capable of doing it.
Excellent, excellent. Is the PT in the unit the power source for the unit?
Yeah, the PT you saw in the picture is one of our partners, Rich Transformers. But yeah, that's part of the external power supply. The controller will take either 120 or 220 or 240 volts. Again, it'll auto select whatever voltage is available. Again, the powering of the external transformer is an option that we can supply. We have a couple particular customers, if they have underbuilt, right, some distribution underneath, then they can actually apply, the external voltage from that. And again, typically underbuilt external power, it's important to obviously have the automation and monitoring. If the AC goes out and the underbuilt, then obviously you're on battery backup. So the battery backup functionality still allows full detection and isolation. There's a little bit of slower delay in terms of the reclosing because of the battery charging piece, but again, full functioning. The external power supply is one of the, I'll call it, the easier packages together. So again, it could be at any one of those voltage classes I talked about.
All right, thank you for that. I don't know if you mentioned this, but what is the maximum voltage level? Will it work for 115 kV?
No, not yet. That's the same utility partner is asking us to get to the books and roll up our sleeves and develop the 138 kV. But this particular product is going to have a maximum system voltage of 72.5 kV. Once we've dispatched and this is a pretty big invention in terms of the jump from solid dielectric completely to the next level 38. So we do have a vision for the 38 kV application, but we'll actually wait till we've dispatched this particular version this year. But yeah, it's a good question, but not yet.
Get there. How do you get the power for the control cabinet?
Yeah, I think it's what you see in the particular picture in that first one is basically external power, solid dielectric PT, right? So that's typically the easiest way. Again, dispatching, as I mentioned, Rich Transformers is a solid dielectric PT. We utilize that particular manufacturer for a lot of our distribution products, and they make a product that obviously does that. Doesn't limit it to that. GE makes also potential transformers that can give us around a little over 2 kVA power requirements that we need. We typically say 2 to 2.5 kVA power requirements from either 120 or 240 volts. So.
Great, thanks, Harry. Are inline tension disconnects recommended?
I think they're a good package, and they're a very simple and really a robust solution. I think we have different variations of opinions because of maybe past experiences, but yeah, we've actually found them to be very robust. We've actually think that they're a pretty good package. Again, especially from a dead end, gives that really quick ability to kind of do some isolation. Again, we don't envision obviously utilities requiring to actually isolate and do things, but they may throughout the life of the product. But they are a very good form factor that allows a very compact installation. So.
All right, almost at time. I think we can squeeze in a couple more. So can you please talk about the changes and modifications to existing poles and infrastructures as the new equipment add vertical and possibly lateral load to the poles?
Yeah, I think that's one of the things that we'll partner in terms of the modeling. Obviously, we can share the center of gravity for any particular installation, any configuration. We can actually share, obviously, the physical CAD drawings to actually modeling. Again, obviously, the infrastructure, what exists today, if it's some, I'll call it maybe lower voltage classes, the infrastructure of a wood pole, it's all going to be based on that particular mechanical strength and whatever form factor. We shared a couple of them in terms of the cross arm. We do also what we'll call as a horizontal bracket, right? All those will dictate and determine exactly the existing pole strength. Again, partnership with our utilities will help to determine and sharing the CAD drawings and again, the center of momentum, where that center of gravity will help make determination whether an existing pole is adequately support and whatever insularities that they do, such as the disconnect switches. So. But again, we can share all the mechanical elements of the product that we're supplying for sure.
Excellent. And how long is the installation process approximately?
The installation in that first variant installation, the utility was obviously, even though they've done we'll call it a beta installation, it was probably about 3 days in terms of infrastructure and learning, but typically within 2 days. The actual reclosers were set within just maybe less than an hour. Lifting and putting them in, making up the conductors of this particular utility in terms of their inline disconnect switches and I'll call it progression. You definitely could do this in 2 to 3 days. The total outage, obviously setting a pole, is a little bit more in the infrastructure associated with that, but from full installation, making up the leads is definitely with only a few days.
Excellent, thanks, Harry. So we have a couple of cost questions. I don't know if you're able to share, or perhaps we can connect you with them after the webinar. But what is the average total cost, including a 651R2? And another question, kind of same vein. They're looking for a rough budgetary cost for a standard unit.
Yeah, I think that's probably be best suited if we can kind of sit with our utilities and kind of go through some of the infrastructure to be able to supply a little bit more pricing piece of the installation. But yeah, we're definitely interested in sharing some of that and working through some of that details with our utilities.
All right, awesome. I think we can squeeze in one more question here. Can you please elaborate on the control power supply and source to the control panel?
Yeah, I think just a general comment that the system does need an external 120 or 240 volt. The packages that we've basically, work with our partner is the rich transformer, but it's a simple feed, 3-wire system that comes with the control, lands to the terminal block, and that one set of, I'll say one source. And again, we can do source transfer, obviously throw over relays and all that type of stuff from either direction. But it basically lands through a string leaf on the bottom of the control. It can be connectorized as well. And then that 120 volt, we basically take care of everything else, right? The control power supply, everything that's integrated and required for operating is just from that external supply. It lands on the terminal blocks and it gives us all the energy we need to fully function the relays, the comms equipment, the battery charging, the actual discharging and operating of that energy to operate the magnetic actuator. So that source of the 120 or 240 can be, like I say, a solid dielectric PT, could be a maybe another oil device, whatever's on standard, or it could be come from the underbuilt, the distribution circuit.
Excellent. We do have some more questions, which we'll connect you with those folks after the webinar, perhaps to kind of reload those. But that's great. A lot of great questions coming in and a lot of great answers. Thank you, Harry, for taking the time to answer those. We do have to conclude the webinar now, but again, I'd like to thank G&W Electric and Harry for taking the time to join us. All of CEA's future events and webinars can be found in our monthly newsletter on current affairs, or on the news and events section on our website at electricity.ca. We will look forward to seeing you on the next session. But for today, thank you everybody for joining us, and stay safe. Bye for now.
Yeah, thank you, Ferran, and thank you everybody for your time today. It's quite enjoyable.